Yes, hi guys. And today, as I promised you, that I'll take in the next lecture series for parametric equation. So now, area of surfaces of revolution, area of surfaces of revolution of parametric equations or biparametric equations, we may say. Okay, so from parametric equations, what is the surface or area of the surface? Okay, what is the area of the surface revolve after revolution of the solid generated by revolution of the parametric equation. This is area of surfaces of revolution, area of surfaces of revolution by parametric equations. We are taking now parametric equations. So far as these questions are concerned, one or two I have taken from polar equations, so that for next topic I have to clarify that how polar equations are also used. In case polar equations are given, then what is the uh, area of the surfaces of revolution, area of surfaces of revolution of these parametric equations. Okay, so now today topic is parametric equation. What the formula for that I'll talk about. I have already talked about in the beginning of previous lecture series that what is the polar form, what is the parametric form, and what is the area of surfaces of a revolution about any other axis other than the two axes x and y. Okay, in this case, two dimension geometry. We are talking about two axes x and y. So other than x and y, if the curve is revolved around any other x then or any other line, that is the fourth topic we talked about. So all those points are already discussed, but today because topic is of parametric equations, so what is the formula for this, what is the function given to us, and how when the functions are given in parametric form. Let me take, if the functions are given in parametric form. What is the parametric form? I've talked about what is parametric. If x and y, the two Cartesian equations, sorry, coordinates are expressed in a third variable. The third variable is known as parameter, and these equations are known as parametric equations. Then what is the problem in parametric form? Then what is the formula or process? What is the process for calculating area of surfaces of revolution? Area of surface of revolution about x-axis and y-axis. We talk about x-axis. Let me take first x-axis. If that, let us take, if the parametric form, equations of parameter or equation of the function, equations, let me take, of the function in parametric form, are, let us take x equal to f into t and y equal to g into t. This is in terms of parameter t. So x is expressed in ft form or in terms of t, y is also expressed in terms of t. Then what we do, we find out ds upon dt. We differentiate these values. This implies that d by dt equal to g dash t. Similarly, dx dt and dx dt equal to f dash t. You will calculate. After that, we calculate what is ds upon dt. Then this is given by dx upon dt whole square plus d by dt whole square. So this is nothing but square root of this g. This is f dash t whole square plus g dash t whole square. In this way, we will calculate the value of ds upon dt. And then, what is the formula for area? Then, area of the surface generated by revolution, area of surface generated by revolution of the curve about, first let me take x-axis, about x-axis is given by 2 pi sine of integration. Here t we will take, let me take t1 to t2, the variable t, so it is parameter t, the value of t will be there. We have to find out t here. This is pi into ds, but this can be written as twice pi. Here t is equal to t1 to t2. Undoubtedly y is here gt. In this case it is gt. Whatever the value of y is given in terms of t, that we will write here into ds upon dt can be written as ds upon dt into dt. ds upon dt in this case is this value that we will substitute here. Then we will integrate it with respect to t. Finally substitute the limits, and after that we will find the solution value. So this is the parametric form here, equation of the area of surface of revolution. Area of the surface generated by revolution of the curve about x-axis is this. This is the formula given here. And about y-axis it will be x into ds upon again dt into dt. So x into dt. This is about x-axis. About y-axis if we have to find out. And about y-axis let me find out. This is about x-axis. And about y-axis we have to find out about y-axis. And area of surface of revolution, about y-axis, or area of surface obtained by or generated by revolution of the curve about x-axis in this, y-axis. Now it is now y-axis, it is about y-axis now. Then the formula is given by again 2 pi. Limits we will take t1 to t2 again in terms of t variable into s into ds. This is twice pi, limit t1 to t2 we will substitute. Value of x we have to substitute here. This is ft because x is given in ft terms, and this is ds upon dt into dt we will find out. Similarly ds upon dt again we have to calculate. That we have to substitute. This is second equation. These are two formulae which we have to use. The area when the curve is revolved about y-axis. That was previous was 2 pi into y ds. This is 2 pi into s ds. Limits are t1 to t2. Okay, so these are two formulae which are used in case of parametric form. When equations are given in parametric form, then we have to find out what is the area of the surface of revolution. Okay, now let me take these questions which I always take from students' queries, online queries, and in the class students have asked me. So those questions I always note down, and then I solve these questions so that they can get answer from my videos on YouTube, Facebook. I'll just drop them there on the Facebook, on Twitter, everywhere I'll just drop them. But at the moment I'm discussing, I'm taking them on YouTube only. After that I'll deliver them there also, because students are asking them on Facebook also. Okay, so I'll take them there also. Now come to the point. Now questions, let me take first question. How to solve the questions. So these are the illustrative questions I've taken from the students' queries so that the topic is crystal clear. Okay, I want to just clarify the doubts of the students because they have asked me to discuss something online so that we can approach you at any time. Okay, so that because of that I have taken these this topic here. Okay, all these topics are taken. Otherwise we were going to write the books only. Book writing is just limited to some people, but this is is spread all all over the world, maybe wherever the people are asking, searching for the knowledge seekers, they can see this. Okay, so that is for them. I'm not asking anybody who is not interested in anything. Okay, that I cannot force. All those people who are knowledge seekers, they can see my videos. Now come to the point. Question number 1 in case of parametric form. So what is the question here? Find the surface of the solid generated by the revolution of the curve x equal to a theta plus sine theta by equal to a into 1 minus cos theta into 1 minus cos theta about x-axis. This is the cycloid we have discussed about. That what is the, this is known as cycloid here, generated by the revolution of the cycloid. This cycloid, all these cycloid are discussed in curve tracing, but the curve tracing is not at the moment so important. But the question is how to solve them. This is the important one. So curve tracing can also be done sometimes so that one can understand that what are the limits for them. Let me take question number 1 here. In case of 1, what is the curve tracing here? If I put, let me first write the curve here. What is the curve? So cycloid given here, cycloids. Here these are the cycloids, form of cycloid. Cycloid, okay, is cycloid is x equal to a into theta plus sine theta. This is first equation in parametric form, and y is equal to a into 1 minus cos theta. This is second one. Now if I just put theta equal to 0 in case of y, what is the form of the curve here? Let me just discuss about that. If I write here, let me take theta equal to 0. So this is 0 cos 1, because cos 0 is 1, so 1 minus 1 0. At 0 it is 0. And when I put pi, this is minus 1 minus plus, it is twice a. At pi it is twice a. At 2 pi it is 0. Why? Because cos 2 pi is 1 positive, 1 minus 1 0. So it is supposed here, let me take, this is the equation here. This is the curve here, I mean. Here theta equal to, let me take 2 pi. We are just increasing from this left hand side. Here theta is equal to, if I put 0 here, this is theta equal to, let me take 0. Or we could write 0 to 2 pi like this, doesn't matter. So this is 0 here, and here it is theta equal to pi. So this is twice a at pi. Here it is theta equal to pi. In this way, the limits are 0 to pi. So, and this in between pi by 2, this is minus pi by 2 plus pi by 2, and so on. This is pi here, this is pi by 2 pi by 3, or this is because we are increasing from this side, or we can take from this side also. 0, then pi by 2, pi, 2 pi by 3, and this 2 pi. Okay, in this way, or this pi here, you can take. But here pi means 2a. That's the curve here. So what is the limits for this? Okay, this curve is revolved about x-axis. In this case, x-axis, I think here, x-axis. The limits are 0 to pi. That is the point. You have to just take this. So this is y-axis. Let me take. This is x-axis here. Okay, this is origin. Let me take. So what about this equation solution? Let me find out. What we do here, first of all we find out dx upon dt, differentiating first and second with respect to t. Sorry, here it is theta, I'm sorry. With respect to theta, we get here theta is the parameter. Okay, so parameter, third variable is theta here. Differentiating with respect to theta, we get dx d theta. First one is a into 1 plus cos theta. This is first. Second, d by d theta is equal to a into, this is minus cos theta, sorry, minus cos theta, so differentiation will be minus sine theta, but minus sign is there, so it is plus sine theta. It is a sine theta. This is second. Okay, first second we have taken, no problem. Therefore, ds d theta, we know that ds d theta, in this case d theta, ds d theta is equal to square root of This is dx upon d theta whole square plus d by d theta whole square. This will give us, now dx d theta is this. This is under root a into 1 plus cos theta. This is whole square. This is whole square. Theta a square into 1 plus cos theta whole square. Okay. Plus d by d theta is this a sin theta. That means a square into sin square theta. This is the value here. Now let me solve it further. It will give us a square. If I take out, then a will come out. It is nothing but 1 plus cos square theta plus 2 cos theta plus sin square theta. Okay, so that will give us a. This is nothing but cos square theta plus sin square theta is 1. 1 plus 1, 2. 2 if I take common, it is 1 plus cos theta. Okay, so that will give us a into, this is under root 2 here. This is 2 into 1 plus cos theta by trigonometric identity. We know that. Cos 2 theta is equal to 2 cos square theta minus 1. Or that means 1 plus cos 2 theta equal to 2 cos square theta. In this case, this is 1 plus cos 2 theta equal to 2 cos square theta. This is trigonometric identity. But in this case, this is 1 plus cos theta. So here angle will be half. So this is 2 into, again 2, sorry, 2 is already there. It is twice into cos square half theta. Angle will be halved. This is cos square, so 2 is also 4. So 2 and cos both can be taken out. It is nothing but twice a into cos half theta. This is the value of ds upon d theta. Now let us find what is the area of the surface. This says what is the area of the solid of the solid generated by. We will find the surface of the solid generated by the revolution. Surface means area of the surface. Okay, so revolution of the curve x equal to this, y equal to this. All right. Let me find out what is area. So ds upon d theta. This we have calculated ds upon d theta. Okay, so let me write here. Therefore, area of the solid generated or area of the surface generated. Therefore, area of the surface generated by revolution of the cycloid from this to this. Now limit here are, as I have told you, 0 to 2 pi. Cycloid about x-axis is equal to twice pi. Let me take out of sign of integration. It is 0 to 2 pi into y into ds. If I take here, let me take p, and this is q. It is r and s. And here this length of the arc is ds delta s. Okay, so that we just calculate. Y into ds here. This can be written as twice pi, 0 to 2 pi. This is y here. Y is that a into 1 minus cos theta. And this is ds upon d theta into d theta. So ds upon d theta is this value. We will get it as 2 pi, 0 to 2 pi. Limits, now this is a into 1 minus cos theta. Still I am writing the same thing. Ds d theta is twice a into cos half theta into d theta. Okay. Now this is 1 minus cos square, 1 minus cos theta. What do we get here? Let me write it here. Therefore, let me write this. Therefore, area A is equal to, this is now 2 to the 4, because this 2 will come out, and this A, and A is A square, and this 1 minus cos theta is 2 sin square theta by 2. So 2 more will come out. Still I'm writing 4a square, let me say. It's 4 pi a square 0 to 2 pi. Now this is 1 minus cos theta, 2 sin square half theta. 2 sin, because 1 minus cos theta is 2 sin square theta by 2 into, here it is cos theta by 2, cos half theta by 2 into d theta. What is this value? Let me fix right now. Okay, so again 2 has come out. This is nothing but 8 here. This is 8 pi a square 0 to 2 pi here. This is now sin square half theta into cos half theta d theta. Now if I substitute the limit here, let 1.2 theta equal to, let me take t here, t, or theta equal to 2t. Differentiating, d theta equal to twice dt. Is it twice dt here? Okay. And what are the limits here then? And the limits will be the limits at theta equal to 2 pi. This is pi. At theta equal to 2 pi, t is equal to pi, because this is theta by 2. If I write here 2 pi in place of theta, 2 pi upon 2 means pi only, so t equal to pi. And at t equal to, theta equal to 0, t is also 0, t is 0. If I put here theta 0, so t is equal to 0, so t is 0. Limits are here, and this is 2 dt, alright. So 2 will again come. This is 16 pi into a square. Here it is now 0 to pi limits, and this is nothing but sin square t, because half theta we are taking t, and this is cos t into dt. 2 dt I have taken 2 outside. This is 16 pi a square. But if it is 0 to a, and if I make it half, then twice will be multiplied again. So this is 32 into pi into a square. We can write it as 0 to pi by 2. Whenever this is a property of definite integrals. When limits are 0 to a, we can make it 0 to a by 2 and multiplying by 2. Multiplying by 2, 16 to the 32 pi a square. And this is now sin square t into cos t into dt. Now we can integrate this by gamma function. What the gamma function it says, let me now write here what the gamma function. Since gamma function 0 to pi by 2, if limits are there, and it is sin power m theta into cos n theta, d theta is given by gamma m plus 1 upon 2 gamma n plus 1 upon 2 divided by twice gamma m plus n plus 2 upon 2. This is the gamma function. Since by gamma function, this is by gamma function. This formula for gamma function, same formula we can apply here. This is 32 into pi a square. Now this is 2 power, so gamma 3 by 2, got 2 plus 1 3, 3 by 2. This is 1 plus 1 2 by 2, gamma 1 upon 2 into gamma 2 plus 1 3 plus 2 5 by 2. Okay, what would this? Now it can be written as 32 pi into a square, and it is gamma 3 by 2. Gamma 1 is 1 only, divided by 2 into 5 by 2. Gamma 5 by 2 can be written as 3 by 2 into gamma 3 by 2. Gamma 3 by 2, gamma 3 by 2 cancel out. Okay, so this is 2 cancel out. It is 32 upon 3. So it is 32 upon 3. Only answer is 32 pi a square upon 2 upon 3, sorry, 32 pi a square upon 3 answer. This is square unit because area is this is square unit, and this is answer 32 pi a square upon 3. This is the answer here. Okay, so question number 1 we have done. Now let me talk about question number 2. Prove that the surface of the solid generated by the revolution of the tractrix x equal to a cos t plus 1.2 a log tan square t by 2 and y equal to a sin t about its asymptote is equal to the surface of a sphere of radius a. Okay, that we will do. What is the shape of the curve here? It's a asymptote. As I did tell you that when we replace this, I mean this is to be converted into parametric form. It's not possible to change it into Cartesian form. So what we do, we put here by find value of x and y. We find first dx upon dt, then dy upon dt, then d by dx is calculated. That means tan theta. D by dx is slope. So d by dx we find out the tracing of this curve we did in curve tracing. Let me first trace the curve and then question number 2 will be done. So question number 2 here is of what kind? Let me just talk about. Now in this case, you find the x and y values at a different value of t, and then d by dx will also be calculated at different value of t. So the coordinates at different value of t in this case, t is the parameter. So at different value of t, for example minus pi by 2, 0, pi by 2, pi. In this way we will take different values. Okay, so on those values, what are the values of x, y, and what you call x, y, and d by dx? So all those values if we calculate, and what is the this is question number 2 here. So here curve is given tractrix. This is the tractrix known as tractrix is given by x equal to a cos t plus 1.2 a log of tan square t by 2 or 1.2 t. Angle is 1.2 t or t by 2, half angle, but tan square is there. Okay, and y is equal to, this is first, and y equal to a cos t, sorry, y equal to a sin t. This is second question. A sin t, a sin t, y equal to a sin t. This is the question number 2 here. So asymptote will be this x-axis. This is x-axis here. This is x dash and this is y and y dash axis. What the curve here? This curve will be like this. On the x-axis, it meets at the infinity. Here it is asymptote. X-axis is the asymptote here. Asymptote. And here it is asymptote. Okay. Similarly, in this case, here asymptote is x-axis. About asymptotes, here t is equal to, this is t here. T equal to 0. Here t equal to pi by 2. We have to take the limits 0 to pi by 2. Now, if this curve is revolved about x-axis, which is the asymptote here, then one curve will be here and this one curve will be here. There are two curves. We have to just revolve this arc first. This is, let me take a point here. This is B point here. So AB arc, if it is revolved about x-axis or about the asymptote here, here x-axis is the asymptote. This is the asymptote. This we have done in curve tracing. So please see my curve tracing lecture. There you will find that how we draw this curve. We took different values for t here and t at, this is pi by 2, this is minus pi here, then here in between pi by 3 or whatever, and then pi by 2, and here pi by 3 in between. This is minus 2 pi by 3 in between. Okay, so this is minus pi here, this is 0 here. Okay, sorry. So in this way, this curve tracing will be there. So this is x-axis, the asymptote here. We have to find out the area of the surface revolve about. X-axis about the asymptote. This arc is revolve about this axis. This arc is revolve about this. If I take limits from 0 to pi by 2, and then twice of this will give us the total area here. So twice I will do, 2 times of the whole area of this arc. This is one arc here. So this arc, if it's revolved, then limits are 0 to pi by 2. Okay. And first let me find out what is dx upon dt, dy upon dt. Solution. Okay. So area of this curve, first let me find out area of the solids obtained by or generated by area of the surface of the solid generated by revolution of the curve, or this arc here of the curve, or first I am taking this positive quadrant here, the arc in the positive quadrant here of the curve about the asymptote. In this case, asymptote is x-axis, or it is here x-axis. So what is the total area? It will be twice into area of the arc AB about asymptote, about the asymptote x-axis. Here x-axis, the asymptote twice we have to multiply. So this will give us 2 into, okay, limits 2 pi into ds. Here limits are 0 to t equal to 0 to pi by 2. This is the basic formula. So it will give us 4 pi. Let me take outside, out of sign of integration, 0 to pi by 2. Here it is y into ds. So first we have to find out this is ds upon dt, and this is t here, okay, into dt. ds upon dt we have to find out y is here, which is a sin t, okay, that we will substitute here. First we have to find out what is ds upon dt. Let me calculate that. So